Eduardo has me on the right track this morning. So I should probably give table 6 a point for that. He asked me last week, he was focused on his test on Friday, as he should be, and he forgot to show me his workbook pages, page 11 and page 12 from last week. If that's you, when we get done talking, you want to come show it to me, we can fix that. And then he also forgot on Friday to turn in his study guide. So at the moment, knowing me, I've typed in a 0 for it. Today is the day you want to make sure you turn in that study guide. Today is the day if you haven't already. If you try to turn it in after tomorrow, I'm going to get you mad and take off a lot of points. Right now, you would just get a perfect score before you did it. But much longer in, it's not really going to be a perfect score anymore. Okay. That does not mean I need you working on that during my class time. You can wait till we get done with notes to do what you should have had done last week. You can. Especially since I posted the key on Google Classroom. Okay, I'm needing help with my new math workshops for this week. Just a gentle reminder that at the end of the 9 weeks, we're going to have a math workshop test. So if you don't understand the concepts, you need to come see me. Is there anyone who wants to volunteer for number 1? Yes, table 2.
X2 plus 2x minus 3x minus b is x2 minus x.
I heard the x2, so x squared.
Oh, I mean 6, not b.
X squared, and then you said plus 2x.
Minus 3x minus 6.
Okay, but you're not quite done.
Which that
Yeah,
would equal x squared minus x equals 6.
Okay, and table 2 can have a point. What they're not telling you that they're doing, just as a general reminder, is they're foiling. A few weeks ago, when we had a problem similar to this, in fact, it was our very first math workshop, we had something like that, and almost everybody in the room tried to foil them in, and they weren't supposed to because of that plus sign. That plus sign just meant combine like terms. And for the love, as a gentle reminder, because I've still got about 3 in here who are trying to make combining like terms way too complicated. When we combine like terms, we seriously just add the people. So x and x is 2x. Negative 3, positive 2 is negative 1. I know that problem's not on the worksheet, but I have a lot who on their test try to make life too complicated and subtract stuff on the same side. And I wrote a lot of question marks on your paper because I was confused. Okay, but back to table 2's problem. They were foiling, so they did first and got x squared, outer and got 2x, inner and got negative 3x, and last and got negative 6. Is there anyone who's not familiar with FOIL? Okay, it's smart of them, and you know you can always show things, that's great, but we're almost to that point in life where honestly you know the outer and the inner are going to combine, so if you just want to tell me your final answer, that's fine. And I drew the arrows this time, but from here on out I'm not drawing the arrows. I see those arrows in my head, I don't have to draw them unless you can on your paper, but I'm not going to on mine. Okay, are there any volunteers for number 2? Yes, table 6. Perfect. So he did the first 3u squared, the outer he got 6u, the inner he got 7u, and last was 14u. In his head he combined the 6 and the 7 and got 13. If you need to write it out, you can. If you can go straight to the answer, that's even more terrific. You can have a point, table 6. Okay, are there any volunteers for number 3? I would love to hear from a group I hadn't heard from lately. You're going to volunteer? Yes, honey.
How did you get 13? She multiplied 7u.
You're good with the 3u squared for that first. You're good with the 6u for the outer. 7u was the inner. Last was the 14. And I went ahead and combined this in my head. We're trying to just save space and time and mental effort. We know the outer and the inner are going to combine. If we can go ahead and do it in our heads, it's less writing we have to do. If you need to write it, it's not a problem. Okay, now I've given you more time to think. Are you ready? Okay. Okay, well. Yeah. Tell me the whole answer, yeah. Okay, so I'm going to think this through really carefully. There's definitely potential for a side arrow on this one. So first, 8q squared, outer, negative 2q, inner, negative 4, negative 4, negative 2. They do make negative 6. He's right. And negative 1 times negative 1 is positive 1. He is completely correct. Yes, dear?
Don't 4 and 5 also have any square methods?
Yes, we're just not going to do them today.
For me, I just started it.
Yeah. And so Arturo is thinking ahead. I was only doing 1 through 3 today because we got a lot of stuff to do. He knows on 4 and 5 on the math workshop. Well, if you didn't add a point already, add a point. He knows on 4 and 5 he's going to need to FOIL as well. It would be smart to go ahead and do those so you could volunteer first for your group tomorrow, especially if you're at a quiet table like 4 or 5. Oh. Okay, are there any questions about our math workshop today? And 13 squared is what? What's 13 squared? Then you can have a point. I heard him first. He started and went first. You can have your point. You bless your heart, you big baby. Okay, let's go ahead and do our new notes. I heard the word checkpoint, and that reminds me, there's a checkpoint on 2.1 tomorrow, just so you know. I did. Okay, so, you know, like you, my brain is on the weekend, so I've got to think this through. A blank is a set of ordered pairs. I know the blanks after this, but a blank is a set of ordered pairs. A blank is a set of ordered pairs. Coordinates? Coordinates is a word that could work. Yeah, I was thinking either point or coordinates. But to be honest with you, considering, say it again.
You said, is that paint?
Points. It's an O. It does look like paint. I already had a dot on the sheet for some reason there. Point or coordinates. After looking at the other definitions that we're about to fill in, though, what we should probably fill in is just X, comma, Y. Okay, you already know how to graph with an ordered pair. And maybe your Algebra 1 teacher made you think about this, but today we're going to focus on domain, which deals with the X values, and range, which deals with the Y values. And then most importantly, what we're talking about today is something called a function. And your teacher made you memorize that one input is paired with one output. So we used to talk about it with a function machine. So like if I send in my batter, I should get out my one cake. So it's supposed to be exactly one element. Each element of the domain is exactly one element of the range. Okay, so I'm going to skip the box in the middle for a second, and let's go down to the first three questions. What we want to look at and see is whether or not each relation is a function. Is it a function? So let's look at number 1. We need to know if exactly one input goes with exactly one output. So for instance, -6 is paired with -1. I don't see any duplicates of -6, so we're good. On that list, do you see 2 x values that are going, like a -6 twice on the list or a -5 twice on the list? No. So this is going to end up being a function. So yes, it's a function. And now to confuse you, not really to confuse you, but to get you used to seeing different forms, we're going to have x and y values in a table. Still same question. Is every x value going to exactly one y value? No, someone says. You want to explain your thoughts and get yourself a point? And? Okay. So we're confused because the number 2 is mapping to 2 different things. It's going to -2 and it's going to +2. That's a problem. It's not a function if whatever we're putting in has 2 different options coming out. So not a function. There is another issue on that list. Well, if you didn't get a point already, you can. There is another issue on that list. Can another group point it out to me? Yes, dear. Yeah, so there are 2 -1s in the x-coordinate, and they're being mapped to both -1 and +1. So we're just confused. We don't know which one. Too many different options. We need our x value to go to only one y value. And then the way Ms. Cummins is kind of making a mapping diagram, our third example actually is a mapping diagram. They've drawn arrows to try to help us. Is this a function or not a function? I heard it is. You want to explain yourself? Ben, you want to explain? If you didn't get a point at seconding a Hunter, you can. Ben, you want to explain yourself? Okay, so the issue is with -8. It's going to -4, and it's going to 14, so it's not a function. Go ahead, Ben. Okay, if you're having trouble reading this third one, because let's face it, it just looks like some random arrows, you can always turn it into a list of ordered pairs. 2, -6, 4, 14, -8, -4, -8, 14, and then we see, oh yes, Ben is correct, we had that -8 trying to go to 2 different things at once. So if you need to make a list like that, you can, just so you know. Okay, and let's go ahead and do number 4 as well. It's on the next page, but it's the same topic. It's got some arrows. We need to know whether or not it is a function. Number 4. It's on the next page. I hear yes, it's a function. I would love, and I hear no, it's not a function. You know, I would love to hear from 4 or 5. They're being super quiet today. They need to start earning them some points. You want to say something today, or you want me to keep giving everyone else the points? Which one, and then why? It's not a function. Is 0 going to 2 things? Or any of the x-coordinates going to 2 things? So is it a function? Okay, you can have a point. That is my name. On number 2, 2 is going to 2 different things. 2 is going to -2, and 2 is going to +2. But right now, like, it's only going to this one. This one's only going to that one. It's if there's two lines pointing out of the same one. That's a good question there. Okay, so far we're still good on what is or is not a function and how to determine it. Now we're going to go back to that chart that we skipped over on the first page. So it used to be enough in your algebra class if you just determined whether or not something was a function. Bless you. Now we got to do more than that. We've got to state the domain. We got to state the range. And we also have to decide if it's a function, what kind of function is it? And there are 3 different kinds that we're going to talk about. The first one that we're going to talk about is one-to-one. And it says that each element of the domain pairs to exactly one unique element of the range. So 1 goes to D, and nobody else goes to D except 1. So if you want to write a note to yourself, 1 goes to D, and no one else except 1 goes to D. I know that seems silly and maybe you don't need to write it, but I have to remind myself because one-to-one and on-to, all the vocab terms start to jumble together in my head. So one-to-one seriously means my one guy is mapped to this one other guy and nobody else can go to D. So if 1's going to D, nobody else can go to D. 2 can't go to D. It's kind of like the seats in our room. Once Will sat down, no one else could go to Will's seat if he's still sitting in his seat. Okay, and then the next kind of function that we're going to talk about is onto. So in the one-to-one, we were saying the domain. So exactly 1 from the domain goes to exactly 1 of the y. When then onto, each element of the range corresponds to an element of the domain. So we're going in reverse. Well, not in reverse. We're saying that every single guy over here has a match. So D has a match. B has a match. C has 2 matches. But notice, for instance, there's not an A up there who doesn't have a friend. If there was a letter in our range or a number and a value in our range that didn't have a friend over here in the domain, it would not be onto. So that's why everyone in the range is mapped to someone in the domain. And just, to make life complicated, some functions get to be both one-to-one and onto. So, yes, exactly 1 in the domain goes to 1 in the range. And everybody in the range has a match. So if I really had to put words with it, one in domain goes to 1 in range. All in range have a match. Domain and range paired. Your group is sitting on my nerves. You're about to lose your point together. Okay, so if I had to put words to it, because, we're going to forget this. We are. We're going to have to practice it a while. So with one-to-one, someone in my domain goes to only 1 in my range. With onto, everybody in my range has a match. And then if you're both, basically we're all pairs. 1 goes with D, 2 goes with D, everybody has a pair. And someone tell me to prove that Ms. Thompson's not crazy and get their group a point. Why this example is not onto, the first one with the one-to-one, why is it not onto? Yes, dear Kelsey. Because C doesn't have anyone to go to. If it's onto, then everyone in the range has someone to go to. Perfect, so you can have a point. Table 4, get it together. Okay. So now we're going to go do our 4 examples again. We're going to have to state the domain, the range, and then we're going to have to decide, is it one-to-one, onto, or both? Or it could be neither. Okay, so again, our domain is our x values. So I'm just going to make a list of all the x values. So I see -6, -5, -3, -1, 6, woohoo. And then for my range, it's all the y values. So -1, -9, -7, 7. And then I don't have to list that -9 again because he's already in my list. And then if you're being a super perfectionist, should you probably rearrange that list of the range and put it in numerical order? -9, -7, -1, 7? Probably. But it's okay the way it is. Okay, we decided this was a function. So now we have to decide, is this 1-to-1? Is this onto? Or is it both? Or is it neither? So I think I'll do this one and I'll let y'all handle the next one. So I'm looking to see, does 1 in my domain go to exactly 1 in my range? One unique element of the range. And that answer is no. I know it's not 1-to-1. And why do I know it's not 1-to-1? Because -5 is going to -9 and 6 is going to -9. So I know it's not 1-to-1, which means it's not going to be both. So maybe it's onto, so let's look at it. Does every element in my range have a match in the domain? 7 has a match, -7, -9, it does. So I would say that this is onto. Are there any questions about number 1? Does everyone understand why it's not 1-to-1? Okay, then let's go to number 2. I need help listing my domain. I'm hoping someone from table 4 will help me list that domain. I'm hoping someone from table 4 will. They need them a point. If not, Seth, it's yours. Let's give them half a second. Table 4, has someone got the domain or range for number 2? Going once. Going twice. Sold to Seth. Seth, tell me the domain and range. Oh, there you go. Thanks. Perfect. I don't have to decide if this is 1-to-1, onto, neither, or both. Why? You can have a point, Seth, by the way. Because it's not a function. Kelsey, you can have another point. We only have to decide 1-to-1, onto, neither, both if it is a function. And on to number 3 we go. Number 3, we already decided it was not a function too, so I don't have to do the 1-to-1, onto, any of that. All I have to do is tell me the domain and range. Table 4. You got it together now? It's about to be sold. Going once. Going twice. Oh, Mia volunteered like 5 minutes ago. Sold to Mia. Go ahead, Mia. 2, 4, -8 for my domain, and my range is... Okay. Yay. Table 2 can have a point. Okay, and now let's move on to number 4. I will still all your joy, and I will list the domain and range. You think about while I'm listing it. Is it 1-to-1, onto, both or neither? I'm interested to hear both opinions on this. Table 1, go ahead. I'm going to you next, ma'am. Yes, Table 1, tell me what you think.
Well, you said it could be either way.
It can be neither.
I said neither.
He says neither. Natalie, what do you think?
On 2?
On 2, and then what do you think, Paige? She thinks both. Okay, Hunter, what do y'all think? You think both? Kelsey, what do you think? Neither, and then Day, you want to share? On 2. Okay, let's think this through. I know that this is your first day dealing with this. I totally get it. Really new. What did I do with my notes? Where did that go? Here it is. We just talked about with on 2. What did we write? What did we write as our note to ourselves about on 2? Do all the numbers in the range have a match right now? No. 8 doesn't have a match, so I know it's not on 2. So my boths and my on 2 people are out. Because of this 8, I know it's not on 2. Because this 8 doesn't have a match. So now we're really asking ourselves, is it 1-to-1 or is it neither? 1-to-1 or neither?
Neither.
Okay, well, let's look back over our notes. We said with 1-to-1, 1 in domain goes to 1 in range. So, let's see. It's going to someone in the range. It's going to someone in the range. It's going to someone in the range. It's going to someone in the range.
It's not.
Well, why is it not? What's the issue? If you can tell me the issue, I'll give you 2 points.
There's no domain going to the range of 8.
That's why it's not on 2, but not why is it not 1-to-1? There's a different reason as to why it's not 1-to-1. Eduardo has got his hand up. Let's get him do it. And then if not, Will, I know you know it. Yes, dear. Okay, our issue as to why it's not 1-to-1 is because both -1 is going to 6 and +1 is going to 6. We have 2 people trying to go to the same guy. I thought we wrote to it to ourselves. 1 goes to 1. 1 in domain goes to 1 in range. That's not 1 going to 1. That's 2 going to 1. So it's not 1-to-1. So we should have written neither. So be honest. If you said neither, you may give your group a point. If you can have 2 for what you explained, yes. But if your group said neither to begin with, you can give your group a point. Yes, it's not any. It's not either one. Good agree. And if you need to explain to yourself why it's not -1 and 1 going to 6. Yes, Will.
Why don't you explain to me?
Because the Lord knows you got enough points. You get 1 point for saying neither. You're about to have more. Trust me. Trust
So what
me.
I said doesn't make no sense.
What you said is why it's not on 2. It's not why it's not 1-to-1. Okay, let's finish. We're still not done with all our life. So we started off today talking about is it a function or not a function, and we had a list of ordered pairs, we had a table, we had this mapping diagram, and Lord knows you're in Algebra 2 Trig, so you're not surprised. Of course, we're going to actually graph stuff. And when you graph things, it's easy to tell whether or not something's at a function or not by the vertical line test, which your teacher might have called the pencil test. Basically, if you take your pencil or your pen or whatever, and you're able to touch your function at 2 spots at the same time, it's not a function. So as I take my pencil and I'm holding it vertically, and I'm going over my function, if I'm able to touch my function at 2 different spots, it fails the test, and it's not a function. For instance, and they show you on your picture, my pen touched this function here. So here's the function. My pen touches it twice at the same time. It touches it here and here. So never mind, it's not a function. It also would double touch here and here, or here and here. And all you have to have is 1 spot, just 1 spot where it would double touch, and it's not a function. Okay, so let's look. We've got an example, number 5. It's not a function. Paige says why. And you can have a point. Okay, so it's not a function because it's failing that test right here. Because look, if I was holding my pen, it would touch it at those two spots at the same time. So not a function. So we don't have to decide 1-to-1, onto neither, both. We don't have to decide any of the things because it's not a function. Okay, and now we have to evaluate a function, which is your favorite part of life. Which is why after I do 4 examples, the last 4 are yours. So evaluating a function is what everyone loves to do. It's literally where they tell you a number to plug into your function, and everywhere you see an x, you put that letter, or that number. So for instance, f of x is 3x minus 5. So f at negative 3 is going to be 3 times, I see an x, so I'm going to put a negative 3 minus 5. Well, I would end up with negative 9 minus 5, which is negative 14. So f at negative 3 is actually negative 14. Again, all we're doing is everywhere you see an x in your function, you replace it with the number in the parentheses. And heck, the truth is you don't just replace it with the number. You replace it with whatever is in the parentheses. If it says f cupcake, then your answer should be 3 parentheses cupcake minus 5. Whatever is in the parentheses, we're going to put in x's spot. Okay, so I'm looking to see who can get in the next one first and get their group a point. Tell me the final answer. And your group gets a point.
So wherever you get
4 for that second one. So our function was x squared minus 2x. So I put in 4 squared minus 2 times 4. 4 squared is 16. 2 times 4 is 8. So I get 16 minus 8, which is 8. Will is correct. Are there any questions about this? This is what most people enjoy doing. That's what I enjoy doing. I know that much. Deciding 1-to-1 onto neither is not as much fun as this. Flip to the back. Now we're going to do 3 and 4, and I'm going to leave 5, 6, 7, and 8 for your homework, and you're going to be mad because 7 and 8 involve fractions. I don't care. Everywhere you see an x, put in the fraction. Okay, so number 5 says f at a, and we have to recall from the previous page, f of x is 3x minus 5. So f at a is going to be what? And Seth gets a point. It's going to be 3a minus 5. Everywhere you see an x, put in an a. Again, if it said f at cupcake, my answer would be 3 cupcake minus 5. And then to recall, g of x is x squared minus 2x. So g at 5n is going to be what? And your group can have a point. Now, Mia is correct, but we could simplify this further, so there's still another point up for grabs. To the group that can simplify this further. $25 what? 25 and you can, Kelsey, how many points does your group have? You have 5? Okay. Mia was correct, but we could keep going and simplify further on that one. And we should, because we can. Okay, the bottom 4 are yours. I know the bell rings in 1 minute, and for that, I'm so sorry. At least one person will get to see their test. If you're dying to know what you made, even if you can't look it over today, come see me.